Microservices are a way to build software applications. Think of them as a collection of small independent services. Each service is designed to do just one thing, and it does that one thing very well. Instead of building a single huge application that handles everything, you build many tiny applications that work together. This approach is called microservice architecture. It structures an application as a suite of loosely coupled services. Each service is self-contained and implements a specific business capability. This modular approach allows for greater flexibility and scalability in the long run. In short, break big problems into smaller, manageable services that can evolve independently. Microservices have become incredibly popular because they solve problems in large, traditional applications. As companies grow, systems become massive and complicated, monoliths that are hard to change. Changing one thread risks unraveling the whole. Microservices let organizations move faster and innovate more quickly. The rise of cloud computing and containers lowered the barrier to deploying many small services. Tools like Docker and Kubernetes are perfectly suited for microservice architectures. Microservices fit small, autonomous teams with independent tech choices and release cadences. They isolate faults, improving resilience. And you can scale only what is hot, saving cost. Popularity drivers: speed, cloud-native tooling, team autonomy, and resilience. First, improve scalability. You scale services independently instead of the entire app. Product browsing may receive 10x the traffic of payment. Scale just the catalog. Targeted scaling uses resources wisely and cuts cost. Second, technological heterogeneity. Each service uses the best-suited tech for its job. Python for ML, Go for high-performance networking, Node.js for UI-facing APIs. Third, faster development. Smaller services are easier to understand, modify, and test. Teams can deploy small, safe changes frequently, core to Agile and DevOps. Finally, fault isolation. Failures are contained to a single service. If recommendations fail, users can still search, add to cart, and purchase. Core functionality stays available, improving user experience and continuity. Despite benefits, microservices add significant complexity. You are managing a distributed system. You must handle latency, fault tolerance, and inter-service messaging. Debugging grows harder. One request may cross many services. Sophisticated observability is required to trace errors end-to-end. Fundamentally, structure. A monolith is one unified codebase and deployable unit. UI, business logic, and data access are bundled into one artifact and deployed together. Like a big house with intertwined plumbing, changing one part risks others. Microservices are many mini applications with separate codebases and data stores. Each house has its own utilities and can be renovated independently. Well-defined streets are like network APIs between services. Monolith updates require redeploying the entire system, slow and risky. Microservices deploy independently, enabling faster, more frequent, lower-risk releases. Organizations shift from layer-based teams to cross-functional teams owning business capabilities. Choose microservices when building a large, complex application that will evolve for years. If your system has distinct business domains, it is a good candidate. Enterprise suites benefit from independent teams working on complex domains. If components need independent scaling, microservices can be cost-effective. Allocate massive resources to compute-heavy services without over-provisioning the rest. Microservices are not a silver bullet. Avoid for small apps or early-stage products with unknown domains. A monolith is simpler to build, test, and deploy initially. Ship faster and learn. If complexity grows, split strategically later. Monolith first is a proven strategy. Adopt microservices only with the right skills and a mature engineering culture. Ensure benefits outweigh operational overhead and architectural complexity. Large tech companies famously transitioned from monoliths to microservices. A streaming app uses hundreds of services: login, history, recommendations, playback. Retail sites assemble pages from many calls, product details, reviews, pricing, shipping. Small teams own services and deploy independently at scale. Ride-sharing, passenger, driver, fare calculation, payments, dispatch, each a service. Scale dispatch during peaks without touching payments or profiles. Music platforms split search, playlists, and personalization for safe experimentation. Teams test new algorithms on small cohorts while core playback stays reliable. Outcomes: scale, velocity, autonomy, and constant innovation. Microservices, being independent apps, communicate over a network. Two primary styles, synchronous and asynchronous. Synchronous is like a phone call. The client waits for the server. Most common protocol, HTTP with REST APIs. Asynchronous is like a text. The sender doesn't wait. Messages go to a queue. Receivers process when ready, decoupling services. Popular tech. Message brokers like RabbitMQ and Apache Kafka. Use sync for request response where immediacy matters, like fetching a profile. Beware long sync chains. Slow or failed services can cascade failures. Use async for background tasks and events. Order placed, inventory updates, notifications. Start with fundamentals. Don't jump straight into Kubernetes. Learn distributed basics and HTTP, REST. Build two small services that talk to each other to learn the basics. Then learn Docker. Write a Docker file, build an image, run a container. Containers are the foundation for microservice deployment. Explore patterns, service discovery, centralized config, and fault tolerance. Leverage frameworks and libraries. Don't reinvent the wheel. Study expert books and engineering blogs to learn real-world lessons. Start small, build incrementally, and learn the why behind the patterns.